Hello, Robert Scribbler here again. Good evening. For the second video for today, I am going to provide an analysis for you of why the U.S. eastern seaboard and the eastern half of the United States, as well as parts of Canada, might see some increasingly severe weather throughout May and possibly into June. So the first screen that I'm looking at here is sea surface temperature anomalies. And the things that I want to point out are that sea surface temperatures in the Gulf of Mexico are much warmer than normal. For most of the Gulf of Mexico, there's a small cool pool off the west coast of Florida. But what we see for the most part is that temperatures in the Gulf of Mexico are between a little more than ½ degree Celsius above average to more than 2 degrees Celsius above average along the coast of the Florida Panhandle, Louisiana, and Alabama. Now, in addition, we have a much warmer than normal pool of water directly off the U.S. East Coast and extending out into the North Atlantic. And these sea surface temperatures range from also more than ½ degree Celsius above average to extremely warm, as much as 5 to 6 degrees Celsius above average, and in many cases above 3 degrees Celsius above average. Now, these two pools of warm water are producing a lot of atmospheric moisture, much more atmospheric moisture than normal. We're going to look at that. So what we are seeing is a lot of precipitable water due to these warm sea surfaces. And as you can see, there's a high pressure system circulating that warm, moist air over the U.S. East Coast. Now, the levels of moisture in the atmosphere are very high over the U.S. Southeast and over much of the eastern half of the U.S., comparable to typical tropical levels of moisture. And this moisture provides fuel for severe weather. Okay, now the second dynamic that we're going to look at is this pool of cooler than normal temperatures. So the region near Hudson Bay and the Canadian archipelago, and I'm going to flip between a couple of views here, is rather cooler than normal. So this is an anomaly map, and what we find is that the region near Hudson Bay, the Canadian archipelago, and in eastern Canada, and also in northern Canada, is cooler than normal. Now, the reason we're seeing this is that there is a trough zone. I'm going to switch to pressure. So what we see is a trough near eastern Canada and Greenland, and this is also visible in the jet stream. So you can see there's an upper level trough right here dipping down, and that's generating these cooler than normal temperatures that we are seeing. So in addition to the cooler than normal temperatures over Canada near Hudson Bay, what we are also seeing is that the southeast and much of the United States is warmer than normal. And so we have a dipole temperature anomaly pattern in which Canada in this region is cooler than normal and the eastern U.S. is warmer than normal. In addition, we have the strong atmospheric moisture levels I mentioned. And so as a result, what we are seeing is more severe weather over the U.S. East Coast. Now, I'm going to talk about a few other factors. So this dipole pattern, I wouldn't say is entirely normal. What we are seeing is that the Arctic Ocean region is warmer than normal at the surface. And these warmer than normal temperatures over the Arctic Ocean region are much warmer than temperatures to the south. So, for example, right now over the Chukchi Sea, we have above freezing temperatures. And in eastern Canada, we have far below freezing temperatures in the range of minus 9.5 degrees Celsius. So, in other words, temperatures that are far to the north over the Arctic Ocean are warmer, and these temperatures are warmer than normal by about 5 degrees centigrade or more in the regions that we were talking about. And the areas of warm air invasion are over the Chukchi Sea, over the high Arctic, and east of Greenland, along a ridge pattern that extends up from Western Europe. So this pattern is not normal. It's associated with polar amplification, and particularly for May, it's quite abnormal. We are seeing temperatures in the Arctic range from 1 to 2 degrees Celsius above average overall, and over the Arctic Ocean, 1.5 to 2.5 degrees Celsius above average, and that's much warmer than normal. And what's happening is we are seeing strong high pressure systems develop in this region in association to this warmth, and these high pressure systems are associated with large ridges in the jet stream, and a cutoff upper level low has remained in place over the Canadian archipelago and eastern Canada for some time, in juxtaposition to much warmer than normal temperatures over the US. So this setup could produce very severe rainfall over the next few days to few weeks over the eastern US, much more intense rainfall than we've seen typically, much more intense storms than we would see typically. And there is some potential for rain bomb events to occur. So again, I'm shifting to the temperature map for today. And as you can see, if you look, for example, here at the Canada-US border, the temperature is near 80 degrees Fahrenheit, 26 degrees Celsius, and you just go a few hundred miles to the north and you've got well below freezing temperatures. Now that dipole is capable of producing very serious instabilities and severe weather, especially considering the moisture loading and high levels of precipitable water that we're seeing in place over the eastern US due to far above normal sea surface temperatures evaporating an excessive amount of moisture into the local atmosphere there. This combination is one, this scenario is a rather unstable weather pattern, and it's a kind of weather pattern that we may continue to see emerge more and more intensely as Greenland melt increases and warming over the Arctic Ocean, it goes through periods of very high temperature spikes. Take a look at the National Weather Service radar. Once again, in conclusion, this is the kind of rainfall that we've seen day after day after day. And there is no likelihood in the immediate future that this pattern will change.